Hey, Trig students. We're learning lesson 10.3 today, which is titled, gosh, I can't remember. Let's see if I can look it up. Stalling. Verify trigonometric identities. I have a cheat sheet for you that I can give to you today, or when you're done with the lesson. But we're going to use our trigonometric identities today. So let's review. First of all, identify a trigonometric function equivalent to the given function. If we remember, 1 over tangent is the same as cotangent. Sine over cosine is the same as tangent. Okay, if you don't remember these, I expect you to know them, so write them down somewhere so you can remember them. 1 over secant. If you remember, secant is the same as 1 over cosine. So 1 over cosine is the same as cosine. And 1 over cosecant is the same as 1 over sine. So 1 over sine is the same as sine theta. Okay, a little bit of a review. Recall that if an angle theta is in standard position with its terminal side intersecting the unit circle at xy, then x equals cosine theta and y equals sine theta. We learned that a few sections ago where sine theta equals y over radius, where the radius of your unit circle is 1. So sine theta equals y. And cosine theta equals x over r, where r is equal to 1 because we have a unit circle. Okay, that's what that's saying. Because xy is on a circle centered at the origin with radius 1, it follows that x squared plus y squared equals 1. Pause. Okay, I am looking at this right up here. Okay, I've redrawn this down there, where that's theta, this is theta. This is my radius. My x value is sine theta. My y value is cosine theta. We know that when we have a right triangle, this is a right triangle, x, y, 1. Pythagorean theorem says that x squared plus y squared equals 1. 1 squared. We can do the same thing here. Sine squared theta plus cosine squared theta equals 1. This right here is true for any value of theta. This right here is true for any value, we can say of theta. All right, we just have a right triangle. So now I'm right here. The equation cosine squared theta plus sine squared theta equals 1 is true for any value of theta. A trigonometric equation that is true for all values of the variable for which both sides of the equation are defined is called a trigonometric identity. Okay, it's an identity. It's something that's true on the left side of the equal sign and the right side of the equal sign, no matter what. All values of the variable are true, so it's called a trig identity. Several fundamental trig identities are listed below. Next slide. Some of which you've already learned. These we already know. The reciprocal identities. These we already know. Tangent and cotangent identities. These are all new. All right, Pythagorean identities. Sine squared plus cosine squared equals 1, which we just learned. 1 plus tangent squared theta equals secant squared theta. 1 plus cotangent squared theta equals cosecant squared theta. We could develop those. I'll show you where they come from, or we're just going to start using them. Cofunction identities, this is that left and right shift. If we take a sine equation and we shift it, it looks like a cosine. If we take a cosine equation and shift it, it can look like a sine. Same with tangent. And then negative angle identities. All right, given that sine theta equals 4 over 5, and theta is in between pi over 2 and pi, that means that this is pi over 2, and here's pi. So sine theta is 4 over 5. We'll say this is theta. Sine is opposite over hypotenuse, so opposite over hypotenuse. The y value is positive, the hypotenuse is positive. We can figure out what the x value is. X squared plus 4 squared equals 5 squared. X squared equals x squared plus 16 equals 25. Subtract 16 from both sides. X equals 3. Sorry. Positive or negative 3. In this case, it's negative 3 because of where we are on our unit circle. So the other 5 trig functions of theta are, we have sine, so we can do cosine. Theta is adjacent over hypotenuse. Oops. Tangent theta is opposite over adjacent, so 4/3. The 3 is negative, so something has to be negative. Cosecant is the reciprocal of sine, so I'm just going to take this and flip it. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. The other 5 trig functions of theta, check. Okay, let's try this a different way. We know that sine theta is 4/5. I'm going to use that Pythagorean identity where sine squared theta plus cosine squared theta equals 1. Plug in 4/5, so 4/5 squared plus cosine squared theta equals 1. I'm going to get out my handy dandy calculator, put it in fraction mode, and have 4/5 squared. That gives me 16 over 25. If I subtract 16 over 25 from both sides, 1 minus I get 9 over 25. Square root of both sides, cosine theta equals 3/5. Right? Now I know I need to be in this quadrant, and cosine value is x over radius, or the hypotenuse, so I need that to be a negative 3. Okay, different way to do the problem. Basically, we know that when we take the square root of both sides of something, we get plus and minus 3/5. We need to figure out whether we're going to use the plus one or the minus one. In this case, I know what quadrant I'm in, and cosine is going to be negative. Then I can do tan theta is sine theta over cosine theta, which is multiply the reciprocal, negative 4/3. So another way to do the same problem, this is going to be negative. I forgot to tell you which one we decided on. And then I can just take the reciprocals of the things I need to take. This would be secant theta is the reciprocal. Cotangent theta is the reciprocal. And cosecant theta is the reciprocal. Another way to do the problem. Cool. I gave a lot of extra slides to do that work and forgot. Okay, we're going to look at another trig expression. Simplify the expression tan pi over 2 minus theta sine theta. All right? If we look at that expression sheet, I'm going to get it for you. Hold on. Okay, I just cut this from the identity sheet that is, or the slide that was earlier on that you have in the book that I photocopied for you. So we know that tan of pi over 2 minus theta is the same as cotangent theta. So I'm going to substitute. I've got, instead of tan pi over 2 minus theta, I'm substituting cotangent theta times sine theta. I know that cotangent theta is the same as cosine theta over sine theta, because it's another thing we've learned, times sine theta. This is sort of over a 1. I'm just showing you that so you can see that I can cancel those two. So that simplifies to just plain old cosine theta. Okay? Another way that I could show this is by multiplying across the top and the bottom. Cosine theta, sine theta over sine theta. I can cross those off. Okay, another simplify the expression. What can I do here? Every time I get a problem like this, I just try to look at it and analyze it. Okay, cosecant is the same as 1 over sine. Cotangent is the same as cosine over sine, and then we have 1 over sine. So these all look pretty good. This one's the messiest, so let's try to simplify the messiest first. So cosecant theta cotangent squared theta plus 1 over sine is the same as cosecant theta. Now it looks like these are the same, so I can factor that out. Let's see. Cosecant theta cotangent squared theta plus 1. So I just factored that out. I just copied this from that slide that has all the identities. 1 plus cotangent squared theta is the same as cotangent squared theta plus 1. I can flip those. What you see is the same as that right there. So cosecant theta, I can substitute cotangent squared theta plus 1 for cosecant squared theta, and that simplifies to 3 of those buggers. Cosecant cubed theta, just like a big puzzle. Find the values for the other 5 trig functions. Now here, I don't care if you draw something. Well, for that last one we could. We probably can. If you want to, I'm in between 0 and pi over 2, so I'm in this quadrant. So cosine theta is adjacent over hypotenuse. So adjacent over hypotenuse. You can use Pythagorean theorem to find that side, or you can use the Pythagorean identity with trig, which is sine squared theta plus cosine squared theta equals 1. Oops. 1/6 squared. So sine squared theta is 1 minus 1/6 squared. 1 minus 1 over 36. Square root of both sides. Sine theta equals the square root of 35 over 6. So now we can just turn everything around, or reciprocal, if cosine plus everything here is positive, so 35 over 6. Secant is the reciprocal of cosine, so 6 over 1. Cosecant is the reciprocal of sine, which you have to rationalize. Stop moaning. Multiply by root 35 over root 35. I get 6 root 35. So that's cosecant. Tangent is going to be sine over cosine over the 6's cancel, and I've got square root of 35. So cotangent is the reciprocal of that, 1 over square root of 35, which rationalizes to square root 35 over 35. So I have cotangent, tangent, cosecant, sine, cosine, and secant. They're all there. Another one. Now I'm in between pi and 3 pi over 2. So that's negative, that's positive. Negative 3/7 squared plus cosine squared theta equals 1. One minus 3/7 squared is 9 over 49. That would give me 40 over 49. Square root of both sides. Plus or minus, in this case, I need it to be the negative. Negative 40 over, negative square root of 40 over 7. 40 breaks into 4 times 10, so 2 root 10. So cosine theta equals negative 2 root 10 over 7. You can't read that, I'm sorry. Negative 2 square root of 10 over 7. So the reciprocal of that is your secant. I know you don't like rationalizing those radicals. I'm going to multiply the top and the bottom by square root of 10. Gives me negative 7 square root 10 over 20. Can't simplify that. So I've got cosine, secant, sine. So your cosecant is going to be a reciprocal of this, negative 7 over 3. I need a new page. I hope you're keeping track. Tangent theta is sine theta over cosine theta. We know that sine theta is negative 3/7. Cosine theta is negative 2 root 10 over 7. The denominators cancel out, and I'm left with negative 3 over negative 2 square root of 10. Okay, the negatives cancel. I have 3 square root 10 over 20. And cotangents. I'm going back to my tangent and doing the reciprocal of that. 2 square root 10 over 3. Cool. Is that all of them? Cotangent. Yep, just checking my answer. Cool. All right, now into the little bit harder ones. Simplifying expressions. It's always like try to make it simple. And I always look for the hardest things and try to break those down. Those two trig functions are the complicated ones, right? So let's write them differently. I have sine x. Cotangent is, if we know tan x is sine x over cosine x, cotangent's the reciprocal. So cosine x over sine x. And then secant is 1 over cosine x. Multiplying, you multiply across the top and the bottom. Sine x, cosine x, 1 over sine x, cosine x. Everything canceled, and that simplifies to 1, which is almost magical, isn't it? Okay, the next one, try to find the things that are complicated and break those down. So tan x, actually, I'm going to break tan x down too. Tan x is sine x over cosine x. Cosecant is 1 over sine x. That's the numerator. Then the denominator, secant, is 1 over cosine x. These cancel. I have 1 over cosine x over 1 over cosine x, which when you divide fractions, you multiply the reciprocal. That's the numerator. That's the denominator. We get 1. Ooh. Okay, here's one of those cofunction identities. I'm in the book looking at the chart. I see that cosine pi over 2 minus theta is the same as sine theta. So I'm going to substitute that. Sine theta minus 1 over, and then if I look at the negative angle identities, I see that sine of negative theta equals negative sine theta. So I'm going to do 1 minus sine theta, because this right here equals negative sine theta. Well, I can do a little bit of magic here, and I can factor out a negative 1 from the numerator, and that will give me negative sine theta plus 1, which I can then rearrange to 1 minus sine theta. And then I can cancel out the numerator and the denominator. Kind of magical. When we're simplifying, we're always trying to take the complicated things and make them more simple.